Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's evaluate the limit of this given special function 1 minus cosine t all over t as t approaches to 0 using table of values. We have here another special function. We have 1 minus cosine t all over t. We are to solve or to illustrate the limit of this said special function using table of values. Again, we have here f of t. Let me just use t because our given has t is equal to 1 minus cosine t over t. And we are to show the limit of the said special function as t approaches to 0. This time, it's called a special function because if you're going to substitute c, because that's our c, oftentimes we use this to solve for limits, right? We don't use other limit theorems. We simply substitute c to solve for limit of polynomial functions, other types of functions. But if you're going to substitute 0 to our given t, t, we will have here f of 0 be equal to 1 minus cosine 0 over 0. Now, it would be even okay if our numerator is not 0 because you will have here a limit that doesn't exist. But it is even more problematic because our numerator is 1 minus 1 over 0, which will give us 0 over 0 because cosine 0 is 1. This is an example of an indeterminate form in calculus, which means it's even more problematic than just saying the limit doesn't exist. This is one of those few times where our f of c is not equal to the limit of f of t or as t approaches to 0 or f of x as x approaches to 0. Because again, this is one of those cases where this is not true. Oftentimes, we just simply substitute the value of c in our function and get the limit and that's it. But not all the time it will result to a specific result because this time this is an indeterminate form. This is why this function is called a special function because the limit is not 0 over 0 but it has a specific limit, and that's the goal of this video. Let us start by of course providing values from the left and right of 0 and plug that in our function and see the trend of f of t as it approaches to a certain value. And if we have equal values from the limit to the left, the limit to the right, that should be the limit of this special function. Supposedly I'm using here x in f of x, but since our given function is t, but of course you can illustrate this if you would like to be have similar situations. You can have x and x. Okay, it's still okay in x here. You can use x, but since the given function, and that's my concern here, I placed here t, so let me just use t in the meantime instead of x. Let me use t, but we will be using values left and right of 0 as t. Okay, t and f of t. So from the left of t, or 0 rather, let's use negative 1, negative 1 half, negative 1 over 10. Okay, so our f of t will be a value after substituting our t on our given function here. As we try negative 1, approximately in 4 decimal places, the value of f of t is negative 0.4597. Approximately that value. You can check that using your own calculator or verify my answer here if it's the same. So with this value, we cannot still give the correct limit from the left, so let's continue with the other values. For negative 0.5, you will have an approximation of negative 0.2448. Next, for negative 0.1, substituting that on our given function, you will have f of t approximately equal to negative 0.0500 because this is approximately, if I'm correct, approximately 4995. But as you round it off into 4 decimal places, let me use this value 500. Okay, so please verify this for this to be clarified further. Now we can see a trend already, but we are not yet sure where it would end. We're not saying it would just end up to negative 0.05. So let's try to use other values even smaller than negative 0.1 just closer to our 0. Let me try negative 0.01, negative 0.001, just until here. Okay. As you plug them in on our calculator, first negative 0.01, you will have here negative 0.0050. As you will try define the last value, you will have negative 0.0005. In short, as your t gets closer to 0 from the left, you will have f of t is getting closer to 0. This is its limit from the left. Let us verify if it's also the limit from the right. So as we pick the values from the right of our 0, let me use 1, 1/2, 1/10. Also 0.01 and 0.001. Similar thing, plugging them in on our calculator step by step, one by one. For 1 or positive 1, you will have here 0.4597. A positive value of this value here. Because if you're going to look into the previous discussion, since we involve here cosine, we can see that cosine, the graph of cosine, will have values of opposite, getting closer to 0 from both sides will have values of different signs but of similar numeric forms. For 0.5, substituting that on our function, again you will have here approximately 0.2448. Then as you continue, you will have here approximately 0.0500. For 0.01 is 0.0050, and for positive 0.001, that's approximately 0.0005. Again, verify this if you can. As our t approaches to 0 from the left, f of t is approaching to 0. So the limit of 1 minus cosine t over t as t approaches 0 from the left is equal to the limit of 1 minus cosine t over t as t approaches 0 from the right, which is equal to 0. In short, this is the entire value of this expression. So as you can see, it's not 0 over 0, but it's just 0 itself. This is an indeterminate form, while this is actually an exact value, a constant value. So again, to clarify, not all the time this will work. So this is just to illustrate that. And this is considered to be a special function because once you see them later in the future discussions, you know that that limit as the given variable approach to 0 is just equal to 0. Thank you very much for watching. So what are you waiting for? Subscribe now.